Now in this section we will see the Hasse diagram. We have seen the various relations. Before that we have seen the properties of relations like reflexive, irreflexive, transitive, symmetric, antisymmetric and asymmetric. From that we have seen equivalence relation as well as partial order relation. So the Hasse diagram is the concept which is related to the partial order relation. And what was the partial order relation? That whatever relation we are having, if that relation satisfies the property of reflexive, antisymmetric and transitive, then we used to say that that is the partial order relation, which we have seen in our last videos as well. The examples we have seen and the concepts we have seen. So the Hasse diagram is related to partial order relation. As we know that partial order relation will not be always in the set format. Maybe we are having a diagram and then we have to find out the simplified version from that partial order relation. The simplified version or simplified representation of partial order relation is nothing but Hasse diagram. Okay. It is used to represent the partial order relation. So as I said, it is satisfying three properties. So how we will do that we will see. First, know that the vertices in the Hasse diagram are denoted by points as well as by the directions. Direction means the edges are always having a particular direction. Now when we are trying to find out the Hasse diagram from the partial order relation, so how we will do that? Which are the properties that are satisfied? Reflexive, antisymmetric and transitive. So from the particular diagram, we have to remove the edge which is showing or satisfying the reflexive property. Then we have to remove the edge which is satisfying the antisymmetric property, and we have to remove the edge which is satisfying the transitive properties. Means the properties which are satisfied by the partial order relation, the representation of that relation is definitely in the type of edges. We have to remove the edges and then we are getting the simplified version, and that is called as a Hasse diagram. So we will see the example. This is a particular partial order relation. We have to draw the Hasse diagram for this partial order relation. So suppose first we will find out the relation for this. So we will start with vertex A. A is related to itself. That means we are having a reflexive term. B is related to itself. Yes, we are having a reflexive term. A is related to B. B is related to C. And A is related to C. Everything is having a particular direction, and because of that we are capable enough to have the particular flow. So this is reflexive term, means these are also antisymmetric, because what is antisymmetric? That if we are having the value of A and B, and if they both are equal, then that was antisymmetric. So indirectly we can say that whenever there is a term reflexive, definitely antisymmetric term is present. That we have already covered. So see, the reflexive terms are there. AB, BC. So the new term becomes AC. That is the transitive term. So according to the rules of Hasse diagram, first we have to remove the reflexive terms. Okay, that means reflexive edges. So what I will do? We will draw the Hasse diagram. distribution diagram. So here we have removed the edges which are